Suspensions. A fella can't get very far without one. Not if he's driving a rig. But why are there so many different kinds? Can the choice of a suspension really influence an operator's total profit picture? Can it change his maintenance costs appreciably? And what about air suspension? Or is that just hot air? Many fleet operators are taking another look. We'd like to consider some of these questions during the next few minutes, especially the matter of air suspension. Let's begin by asking what a suspension is really for anyway. The fact is, if roads were perfectly smooth, a vehicle wouldn't need any suspension at all. But unfortunately, roads can't be made that way, and springless, rigid suspensions aren't practical at speeds above a crawl. The purpose of a suspension is to help iron out the bumps and irregularities in the road. It attempts to do this by permitting the wheels to move independently with respect to the rest of the vehicle, thus cushioning the jolts that would otherwise be transmitted to the vehicle chassis, the cargo, and the driver and passenger. Early suspensions were only partially successful in this regard. Engineers have tried many different kinds of springs for suspending vehicles on their axles. There were buggy-style elliptical leaf springs. More recent semi-elliptic spring stacks. Coil springs. Steel torsion springs. Rubber in compression. Rubber in shear. Combinations of rubber and helical springs. And pneumatic springs that float the vehicle on a cushion of air. It is the most highly developed of these pneumatic springs, Firestone Airide Springs, that we want to talk about. We'd like to explain what they are, what they do, and why they result in improved, more profitable operations. The simplest kind of an air spring is a piston operating in a cylinder, taking advantage of the inherent springiness of air as it is compressed. Such air springs actually were used on vehicles as early as the Civil War period, but the piston seals tend to leak, and their friction adds too much harshness to the ride. Modern Firestone air springs look like sophisticated balloons, but they are actually highly engineered packages of compressed air, designed to change their shape under dynamic conditions in order to produce ideal spring characteristics. Just how sophisticated they have become is indicated by the fact that air springs have been under development for more than a century, with a number of dead ends investigated along the way. Some of these efforts had no chance of working satisfactorily. Technology just had not matured sufficiently. Others were released before attendant plumbing and equipment were properly developed. Indeed, there has been some justifiable criticism directed at air suspension trailers employing some of these early designs. For the plain fact is that there is no magic in air unless an air spring, as on this modern suspension, is designed to take advantage of air's unique characteristics. Modern air suspension began at Firestone about 30 years ago, when inventor Roy Brown and his men set out to develop a pneumatic spring that would take advantage of all the desirable properties of air. His success can be measured by the family of more than 100 designs of Airide springs which Firestone manufactures today. Air springs that carry loads from a few pounds to as much as 15 tons apiece. These are produced in Firestone's Airide plant at Noblesville, Indiana, using processes that have been developed over a period of 30 years. These processes include calendaring, cord bias cutting, building, and curing the air spring. After curing or balkanization, bead plates generally are crimped over the ends, creating a hermetically sealed assembly. Every Airide assembly shipped out of Firestone's Noblesville plant is checked for air tightness and proof tested at twice the maximum design load. An Airide spring hardly seems strong enough to support a vehicle, and in fact it doesn't. The vehicle is supported by a column of compressed air enclosed by the flexible walls of the package, which are made of oil and salt-resistant synthetic rubber reinforced with multiple plies of high tensile strength nylon tire cord, locked in place around metal bead wires. The resulting assembly can withstand many times the operating pressure for which it was designed. These are some of the reasons why Firestone's modern Airide springs have been so successful. Continuing development and evaluation in the physical testing laboratory is another. But what do air springs offer that more conventional spring suspensions don't? Airide not only makes possible a much softer suspension, but one that stays soft, whether the vehicle is empty or loaded. Here is a simple experiment that dramatically demonstrates how Airide springs can smooth out the bumps. The ping-pong ball container on the right is fastened directly to the axle. The one on the left is on the isolated cargo side of the air spring. You don't need an accelerometer to see the difference. Airide not only makes possible a softer suspension, but one that stays soft whether the vehicle is empty or loaded. Compare these ride meter traces which measure the ride on two vehicles driven over the same road. If you don't have this kind of instrumentation, a fairly easy way to measure the softness of a suspension is to bounce it up and down at its so-called natural frequency and count the number of bounces in 1 minute. The lower the number, the softer the suspension, and the better the isolation from road shock. If the result is over 100 bounces or cycles per minute, the suspension will probably be hard on passengers. If it is over 150 cycles per minute, it will be hard on the cargo and the vehicle itself. The problem with conventional springs is that the natural frequency doesn't stay put. Everyone knows that most vehicles have a pretty good ride when they are loaded. It is a rough, empty ride that tears up the chassis and the maintenance budget, especially when interleaf friction adds to the shock of high natural frequencies. This becomes clear if we simply suspend a weight on a conventional spring. With a heavy load, the natural frequency is about 130 cycles per minute. But as the load is removed, the natural frequency goes up to 190 cycles per minute. Now let's try the same experiment with an Airide spring. Under the heavy load, the natural frequency is only 55 cycles per minute. But with the heavy load removed, the frequency still is only 59 cycles per minute. Comparing the resulting traces makes it obvious that the Airide spring, shown on the right, produces a much softer and more constant ride, free from the harshness of frictional damping. What this means is that with air suspension, the cargo, the passengers, and the vehicle get the same soft ride under all conditions of loading. And because destructive road shock is eliminated, tires last up to 60% longer. As a result, conventional springs on buses are virtually obsolete. Since going over to Airide in 1953, one principal bus operator has saved about $1 million per year in spring maintenance alone. Many of these coaches have gone over 1 million miles on their first set of Firestone Airides. That the passengers enjoy a softer ride is common knowledge. That the coaches themselves last much longer is now an established fact. Similarly, operators of tank trailers particularly appreciate the constant softness of Airide, since tankers must operate empty about half the time. And it is the empty tanker that is damaged by pounding over the road, particularly the modern tanks made of lightweight metals. Moreover, no one knows that a leak has developed until it is too late. Then the tank must be emptied and flushed out before it can be safely welded. Meanwhile, the trailer isn't earning any money while it's in the repair shop. On Firestone air suspension, an empty tanker rides as softly as a full one, and the tanks, even aluminum tanks, last much longer since they are cushioned from destructive road shock. Fragile cargoes get to their destination without damage claims on air rides. Many shippers have found they can cut packaging costs. The military services now protect sensitive electronic equipment and missile instrumentation on air suspension. Eggs shipped on air, free from scrambling vibration, handle grade A upon arrival. And here are some passengers that appreciate the softness of Airide. But their owners appreciate it even more. Cattle haulers have found that animals lose less weight when they travel to market on air. Horses arrive actually fresh for racing. Drivers naturally are less fatigued, do a safer job. Because Airide cushions the vehicle itself, the whole structure can be made lighter. This truck manufacturer saved nearly a ton of dead weight in its Airide tractor design, adding the same weight to payload profits. And not only does the vehicle chassis last longer, there is evidence that Airide axles are actually easier on the road itself. The softness and compactness of air suspension helped make possible this unique van with 35 feet of doors on a 38-foot trailer. This same van has air rides in the fifth wheel section as well as in the suspension, thus floating the entire trailer on air, regardless of the kind of tractor used. Another special vehicle made possible by air suspension is this unique trailer, which operates like a 40-foot tandem on the highway, but splits apart into two 20-foot single-axle units for local delivery. And the fact that the axles are pneumatically coupled provides precise load equalization without heavy mechanical interconnections. By contrast, a very different special Airide vehicle is this three-wheeled electric postal truck. Railroad air suspension today provides passenger comfort on commuter trains and rapid transit cars and permits lightweight construction on these coaches. On Air Force radar trains, Airides cushion electronic components. Let's take a minute to look over a typical air suspension system. In addition to the Airide springs themselves, there are leveling valves with plumbing leading to a reservoir air tank. that is filled by the air compressor after the air brake system is up to pressure. To simplify things a bit, the vehicle, as we have seen, is supported on columns of compressed air enclosed by the Airide spring packages. As load is added to the vehicle, the air is further compressed and the body sinks down, opening the leveling valves and admitting air to the springs from the reserve tank. As the pressure in the air springs increases, the vehicle body returns to its original height and the valves automatically shut off. If the load is removed from the vehicle, the valves open to the atmosphere, bleeding off excess air pressure until the vehicle is re-leveled. But the real secret of air suspension is that each time the vehicle is re-leveled, it is this same change in air pressure inside the Airide springs that also makes them softer or stiffer, as necessary to compensate for changes in load, thus retaining the same natural frequency, the same ride under all conditions of loading. But the leveling itself has advantages. Constant platform height is an obvious one. The bed is the same height no matter what the load. And the bed remains level no matter where the load is placed. On buses, this means constant step height. Moreover, because the vehicle does not sink down under load, as it does with conventional springs, the chassis can be designed for constant overhead and road clearances. On a 35-foot trailer, this can add 70 cubic feet of payload volume. With the addition of manual valves, other unique functions can be performed with this leveling feature. Using the Airide springs as pneumatic jacks or actuators, for example, saves hours in moving heavy equipment. This same sort of technique can be used to move the vehicle through tight vertical clearances, such as loading aboard aircraft or shipboard. Because air balances the load between axles and eliminates friction, Airide vehicles can achieve phenomenally good load equalization. An operator thus can load right up to the legal limit without risking a fine. And trimmer controls can actually shift the load and adjust each axle to carry its maximum permitted capacity. One question frequently asked by operators contemplating their first purchase of an Airide vehicle is, what happens in the event of damage to some part of the air system? Modern air suspensions have a system of check valves which localize and minimize the effects of any such damage. But Firestone Airide springs also have a built-in safety feature. If a spring should be deflated, it merely settles down on the internal rubber compression bumper and the control and mobility of the vehicle remain unimpaired. And if an air spring ever requires replacement, the job can be done in 30 minutes time, as compared with 4 to 8 hours with other types of springs. To summarize then, by overcoming road shock and vibration, Airide offers these advantages. Reduced operating costs through decreased vehicle maintenance, reduced cargo damage, increased vehicle life, increased tire life, and greater driver comfort and safety. Airide also means increased payloads because of reduced vehicle weight and increased cubic content as a result of leveling. Leveling also means loading convenience with constant or adjustable platform height, pneumatic jacking, and other special techniques that are afforded only by air suspension. We have implied that not all air springs take advantage of the unique characteristics of air. One way to be sure you are getting the benefits of modern engineering research and development in your air suspension is to look for this trademark. For modern Firestone Airide springs are indeed a soft touch to the operating budget as to the vehicle and cargo. Firestone Airide, in fact, has sired a whole new family of vehicles and has made possible suspension designs that herald a new era in commercial vehicle progress.